So this is one of the many classes included in your modules. We don't have this package. If you have this package, you will not be able to compile this. So this is ArrayBoundedQueue, a generic class, a concrete class that implements a queue interface. It's the generic interface that implements a data T. This data T could be an integer class, a string class, or what have you. Inside the queue, what you have is a collection, array of T elements. This array T elements uses a Java native object with a default cap size. This default capacity is 100. You can change this 100 to any numbers you like, 200, 3,000, and whatnot. Just don't make it, 1 million, because it just makes no sense to have an array that large. You don't know if you're ever going to fill that one up. The other problem is each integer in Java is 4 bytes. Integer is a class. Even from a native standpoint, that's like 8 megabytes. So you don't want to do that. This is a default constructor. A custom constructor uses a max size. Whatever this max size is what you passed in, which initializes the underlying collection to be of that size. Your rare is max size minus 1. This is our initialization. There's a couple of initialization that we need to look at. The first initialization calls for number elements. Empty queue, number elements 0. Front and rear. Front and rear represents the index of the array. Front, this is your member variables, part of this class. They're basically loaded in the class before your constructor happens. All of these elements will be loaded in memory with this numbers inside. Front is index 0. Rear is not initialized until construction time. This is max minus 1 or decap minus 1. So max size or decap both represents the size of your underlying collection minus 1 because array indexing is always 0. So by default, Java assigns a value of 0 for any integer not initialized. This one is a memory allocation that allocates this fixed size array inside the constructors. Let's look at both transformers. The most important transformers in queue. Number 2 is called dequeue. One of them is adding the elements to it, and the other one is removing an element from it. The third set of operations are observers. So these observers are assessors that tells you something about the properties of the array. Is this array empty or not? Is this array full or not? What is the size of the array? So what is the size of the array? The size of the array is the number of elements. On an empty queue, your number of elements is 0. That returns the size of it. But as you add more or in-queue more elements to it up until that size, you're not going to exceed the capacity of your queue. Is full is checking to see number element equals the element's length. This is the underlying collection. Array in Java is a class. This element is an array object. This array object has a property called length. In order to invoke that property on the object, you have to do a dot operator. So this element's dot length gives you the size of the underlying capacity of collection. If the number of elements equals that, then it's full. On the other hand, if the number of elements equals 0, that means this queue is empty. Let's go back and talk about in queue, the most important operation, and then we'll talk about dequeue. In queue means that you're adding an element to this entire queue. Let me just draw this collections out initially. This is your front. Rear points to max size minus 1 or decap minus 1. This is index 0. We use a custom constructor and we pass in the max size. So your index R is pointing at max size minus 1. If this entire queue is full, meaning the number of elements is at the capacity already, you want to call queue overflow exception. Recall that this exception extends Java runtime. This allows you to throw an exception with a message. This part is not as important for us. You definitely want to capture the exceptions. This queue overflow exception, if not caught, is going to stop your Java code. Let's just focus on the else part. Assuming you still have capacity, meaning this entire queue is not full, num elements equals num elements plus 1. Num elements plus plus, check. This in queue means that we're adding an element, and this element is A. This is element A. So T is a string. String is a double quote. Recall that rare used to be at the end. If you add 1 to it, this rare is going to be at the very beginning. This rare is not going to be decremented by 1, by 2, by 3, but it's going to be shifted. Rare plus 1 is going to take you into max size. But max size is elements dot length. Max size could be the default 100. If you do rare plus 1 and mod this entire thing, That takes you to rear 0. Rear was max -1. Max size gives you 0. For the edge case where you have an empty queue and you just add 1 to it, this rear is going to be 0. After adding just one element, your front and rear are both at index 0. Let's take a look at the other edge cases where you already have something in there. Let's say if you have A and B, and now you want to slot this C into it. Your front is still going to be at 0. Rear is 1. Rear plus 1. Rear is going to be 2. 2 mod number length is going to be 2. This gives you the ability to keep track of your F and R. InQ doesn't care about your front. You want to keep the rear pointer. InQ also cares about the number elements. And DQ too. DQ cares about your number elements. Every time you do InQ, num elements increments. Every time you do a DQ, DQ decrements the number elements. So let's look at the DQ part, where you have nothing to DQ anymore. This throws the underflow exceptions. Let's focus this part. When you DQ something, you have to return the elements. This means there is return at the end. You want to fetch whatever is the front. Let's say if your front is here, and this is your index n. Front at this index n gives you this element. This element is the to return. And the reason why we have to create this temporary variable is because we have to nullify that part. If you just say elements front equals null, the entire element is going to be gone. Let's say this is A right here. We're talking about indirect addressing. A is a reference to a object sitting in some memory location that contains a value of A. So that reference has to be stored inside this to return, and then you return it. A number element decrements by 1 because you're DQing something. This also works. So let's look at front equals front plus 1 elements length. If you DQ something, you have to move your front forward. The entire queue grows from left to right. This goes into that circular floating front design. You have to do a modulus elements length to keep track of your front and back. It is very possible that when you do front plus 1, your front is already at the end. So n is max size -1. So front could be here. If you do front plus 1, that's going to take you over here, starting from scratch. Because you have your num elements to keep track of the total elements, this prevents both front and rear from crossing each other. So this is essentially the DQ operation. Combining DQ, InQ, and observers is how this array bounded queue is implemented.